5G is enabling technology for building cities resistant to natural disaster. What is 5G? 5G networks is the fifth generation of mobile internet connectivity, offering faster speeds and more reliable connections for smartphones and other devices. With 5G, data transmitted over wireless broadband connections could travel at rates as high as 20 gigabit per second by some estimates, which exceed wireline network speeds, as well as offer latency of 1 millisecond or lower for users that require real-time feedback. 5G will also enable a sharp increase in the amount of data transmitted over wireless systems due to more available bandwidth and advanced antenna technology, allowing for a smarter and more connected world. In addition to improvements in speed, capacity, and latency, 5G offers network management features, among them network slicing, which allows mobile operators to create multiple virtual networks within a single physical 5G network. This capability will enable wireless network connections to support specific users or business cases. For example, a self-driving car would require a network slice that offers an extremely fast, low-latency connection so a vehicle can navigate in real time. 5G network is also useful in Internet of Things (IoT) and natural disaster management. So, how does 5G works? 5G technology will achieve its expected high efficiency using most modern modulation techniques and network terminologies like carrier aggregation (CA). CA is a technique used in long-term evolution (LTE) standard to improve the system efficiency. In carrier aggregation (CA), two or more carrier signals are aggregated to support wider bandwidth, which allows even up to 100 MHz. CA uses three techniques for aggregation. Intraband contiguous, where two carriers are transmitted at neighboring channels. Intraband non-contiguous, where two carriers are transmitted with channel spacing. And interband. In this technique, different LTE bands are used for transmission simultaneously. Next, there is small cell concept. Small cell is a term which uses low-powered radio access nodes to help provide service to both indoor and outdoor areas. There are three types of cells: femtocell, picocell, and microcell. A few advantages of the concepts are to increase capacity in areas with high user densities, improve coverage, and also to reduce power consumption. Next, we have MIMO concept. MIMO is a transmission technology with the usage of multiple antennas for transmission and reception. Simultaneous data transfer is possible using this technology, thus offer efficient data rate. The more the number of antennas, the more the transmission and reception can be done. Wi-Fi offloading. Wi-Fi offloading is one of the main features of the future networks. It allows the user to connect using Wi-Fi network, and the cellular network can be allocated to other users. It will be suitable for some places where cellular network quality is poor and users still have the option to connect to the network without cellular reception. Device-to-device communication. D2D communication is a technique where two adjacent devices communicate with each other directly. Network will have the control over the devices and allows an operator to determine the traffic routing between direct and network path. During the absence of network, one device can connect to another device. Cloud, radio access network. CRAN is a network technology used for effective communication with a centralized information processing carried out remotely within the cloud system. The signal will be processed at a remote location and the base stations will be connected with most efficient fiber optic connections. Some of the advantages from implementing this technology are a more simplified network, cost-effective due to less hardware requirements, and increased network flexibility. But how can 5G help during natural disaster? First of all, 5G can fix wireless broadband services. To do that, network operators deploy new radio (NR) in small cell sites near buildings to beam a signal to a receiver on a rooftop or a window that is amplified within the premises. Fixed broadband services are expected to make it less expensive for operators to deliver broadband services to homes and businesses because this approach eliminates the need to roll out fiber optic lines to every residences. Instead, operators need only install fiber optic to cell sites and customers receive broadband services through wireless modems located in their residences or businesses. 5G cellular service. This provides user access to the operator's 5G cellular networks. These services will begin to be rolled out when the first 5G-enabled devices are expected to become commercially available. Cellular service delivery is also dependent upon the completion of mobile call standards by 3GPP in late 2018. Ambulance operations are an essential part of the emergency services, and over the past few decades have become increasingly advanced with large number of fairly high-tech medical equipments and devices. However, with the widespread rollout of 5G wireless communication network, the traditional ambulance could soon be replaced by the 5G-powered super ambulance. Features such as high-definition video communication, computed tomography (CT), and X-ray scans would connect to both the emergency vehicle itself as well as the hospital or emergency department that the ambulance was either dispatched from or on the way to. Lower levels of latency and enhanced speed and reliability makes 5G wireless networks an ideal architecture to base such services on. By keeping up to constant, reliable and high-quality communications between both the super ambulance and the emergency center, 5G networks could allow for remote diagnosis from doctors stationed in specialty departments that were not local to the scene of the accident or emergency. By collecting as much medical and observational data as possible on board the vehicle itself, super ambulances would also collect and send this data to their destination, prepping the hospital for incoming patients before they arrive as well as enabling more time to diagnose them. Firefighting and medical delivery drones. Drones are never too far away these days, it would seem. From companies like Amazon that are planning on utilizing them for delivery services, to their various uses in safety, surveillance, or entertainment. Remote controlled drones are becoming an increasingly common aspect in our modern daily lives. Despite having been commercially available for some time now, it has taken up until fairly recently for drones to become credible candidates for utilization within emergency services. Firefighting, for example, is one way in which multiple drones operating on a 5G network and being remotely controlled by a human operator could be used to tackle emergency or natural disaster situations more effectively while also reducing the risk to human lives. The delivery of emergency medical supplies to hospitals or disaster areas is another way in which 5G wireless communications network could allow drones to enhance the methods and technological resources of emergency services and disaster relief efforts, minimizing the risk of delays such as traffic or human error in the delivery of vital assets. Be it deliveries, surveillances, entertainment, emergency medical transportation, firefighting, or any other application of drones, 5G networks will ensure they become a feasible solution to this and many other challenges in the future. Intelligent Transport System (ITS), prioritization, and network slicing. Some of the more technical benefits of 5G wireless communications networks for emergency and public services would be the ability of this kind of networks to allow for the prioritization of vehicles using ITS and their capability for network slicing, which essentially guarantees that the network services used by medical or any other mission-critical industries are not interrupted or affected by increases in the usage of others nearby. Using 5G wireless communication system to communicate, emergency service vehicles like the super ambulances will be able to alert traffic management systems of their approach and enable them to modify traffic so as to provide an optimal route for the emergency service vehicle to its destination. Network slicing in particular has become something of a big deal for emergency services and first responders, as one of the biggest challenges faced by them during natural disasters and emergencies were maintaining an adequate communication between the emergency services team, disaster relief teams, and the various search and rescue teams involved. Remote surgery. Beyond speed, the biggest benefit of 5G is its low latency, or the short lag time between a device pinging the network and getting a response. While not necessarily noticeable, there is a lag with 4G LTE network. A 5G network virtually eliminates its meaning in the future. A surgeon may not need to be in the same room to treat a patient. This technology allows the doctor to perform surgery on a patient without being physically in the same location. How this technology works is that a surgeon will use a virtual reality headset that shows the patient and its surrounding and a pair of gloves to control a robotic arm that will perform an actual operation on the patient. The glove is fitted with haptic feedback motors that will give feedback when you touch the patient, giving the surgeon the sensation that if he were to actually touch the patient. Companies are calling this idea the Internet of Skills, that enable the transfer of expertise over a great distance in real time using robotic and haptic feedback. This is the end and thank you for watching. If you have any questions, please leave it in the comment box below. We'll be sure to answer them.